Now let's look at intercept form. We're going to graph an intercept form. I think personally this is the easiest format of all. All right, so we're graphing the function f of x equals negative x plus 2 times x minus 4 to determine whether the graph opens upward or downward. I don't know what my thing is about negatives because this is the third time in a row that we have a negative a value. I'm going to graph some positive ones. I promise. Next lesson, we're going to have all positives, or some positives. I'm trying to write since. Since a equals negative 1, our graph opens downward. Or I could say it's concave down. Onto the axis of symmetry. All right, so to find the axis of symmetry, you take P and Q. All right, so remember the format for intercept form. F of x equals a times x minus p, x minus q. So notice there's a negative next to the 4, right? That goes with the equation. So q there, that particular q, and why it's p and q? Because those letters weren't being used. That's why. If I write it down there and I move it up. The worst is the equals. Well, at least that one looks like it equals. All right, so when we're adding those two values together, since it's a x minus 4, the minus stays with the equation and the value is actually 4. All right, now we have a x plus 2, which means that's really x minus negative 2 because the negative has to stay with the equation. So we have negative 2 plus 4. And then we take that and divide by 2. We take the average. Because your vertex, I said in a previous lesson, your vertex is halfway between your x-intercepts. If that's confusing to remember the sign of your P and your Q, right? So trying to remember that it's minus and negative. The other thing you can do is find your x-intercepts. That's your P and Q, right? So before I even finish finding the vertex, I'm just going to stroll down here to find the x-intercepts, right? So if you don't want to have to identify P and Q, and you want to just find your x-intercepts first, because nobody says you have to find vertex first, you'd plug in 0 for the f of x, negative x plus 2, x minus 4. And so if you divided by negative 1, your factors would still be equal to 0. So 0 equals x plus 2 times x minus 4. And so you're still going to have the exact same factors. And if we set our remember the zero product rule, that if you have two numbers, two values, and when you multiply them, their product is 0, that means the factors have to be 0. Because you only get 0 as a product if you multiply by 0. So that means x plus 2 is 0. And if I subtract 2 from both sides, we see x is negative 2. X minus 4 is 0. If I add 4 to both sides, we see x is 4. And if you take a look, that's exactly what I added up there for P and Q. All right? So, and it doesn't matter who's P and who's Q. It's just we're taking the average of those, adding those two values and dividing by 2. So in this case, if I look at it just the way I have it written, P was negative 2 and the Q was 4. And notice those are our x-intercepts. So the P and the Q for intercept form, that's really just your x-intercepts. All right? So if you don't want to have to think of it as P and Q and remembering that it's, if it's x plus 2, it's minus a negative, then just find your x-intercepts and add those and divide by 2. It's the same thing. All right? So P and Q, I'll put it up here. also the x-intercepts. Right, so find your x-intercepts, add those and divide by 2. However, it makes more sense for you because it's the same thing. Now that we have our x-intercepts already done, let's find our axis of symmetry and our vertex. Right, so if we add our x-intercepts, negative 2 plus 4, we get a positive 2. And if we divide that by 2, h equals 1 is our axis of symmetry. And since it's a vertical line through the x-axis, let's write that as x equals 1. So h equals 1 means that it's the x-coordinate of our vertex. It's also the point that the axis of symmetry goes through, right? And so, but we usually write vertical lines as x equals a constant. So for the axis of symmetry, let's make it x equals a constant. That constant happens to be the x-coordinate of our vertex. Because remember I said the vertex was halfway between your x-intercepts. So 1 is halfway between negative 2 and 4. Now we just need the y-coordinate, and to find the y-coordinate, we're just going to plug in the 1. And that's the only way you have for this, but that's okay. It's super easy. You're just adding and multiplying. You can do that. So we have negative 1 times 1 plus 2 times 1 minus 4. So f of 1, we have negative 1 plus 2 is 3. 1 minus 4 is negative 3. Look at that, the distances. So by the way, those are just end up being the distances from your x-intercepts to your vertex. How about that? So we have negative 1 times negative 3 times another negative, right, is going to be a positive 9. So that is the y-coordinate of your vertex. Right? So we've got our vertex, we've got our x-intercepts, our axis of symmetry, the direction. All we need is the y-intercept. And always, to find any y-intercept, no matter what it is, you just plug in 0 for x, because that's the value of x on the y-axis. Right? And when you simplify, you'll have your y-intercept. So 0 minus 4. So I've got f of 0 is negative 0 plus 2 times 0 minus 4. So that's just going to be a negative times 2 times negative 4. So our y-intercept is positive 8. Right? So our y-intercept is 0, 8, vertex 1, 9, and our x-intercepts, see if I can squeeze it in there, negative 2, 0, and 4, 0. Let's just graph everything on the next page and we're done. So this actually was my quickest podcast. I told you intercept form was the easiest. And by the way, if you can't write things down, remember you have a pause button. You can pause me, right? Or just watch me again. I think I'm delightful to watch, actually. All right, so let's graph our function here. Our axis of symmetry was x equals 1. The vertex was, now I forgot, it was a 9. Oh, it was 1, 9, wasn't it? Yes. Almost forgot what the y was, but then I remembered. Our y-intercept was 0, 8. X-intercept, easy to find. You can even look at the graph and see it. Negative 2, 0, at the equation and see it. And 4, 0. And let's just graph our points. And my axis of symmetry is the green line. Let's graph that. Because, the good thing about the axis of symmetry is, it helps us to divide our graph in half. So it makes it easy to find those, I call them bonus points. The points we didn't have to do any work for, just we're using the fact that the graph is symmetric. And whatever's on the right-hand side is also on the left-hand side. So 1, 9, 4, 5, 6, 7, 8, 9. And so next time, let's graph some graphs that aren't all concave down. 0, 8 is right here. And so let's write that down. 1, 9, 0, 8. So here's our bonus point, right? So there has to be a point over here on the other side. And so that would be 2, 8. And how did I know it was 2? Well, it's 1, 2 on the x-axis. Nothing special. I just identified the point it's located at. And then negative 2, 0 was an x-intercept. Yes, it was an x-intercept. And 4, 0 is our other x-intercept. And now we play connect the dots and make sure it's U-shaped. Do your best to make it U-shaped and symmetric. Right? It's not a B. And all we need is domain and range. And we know every single time you can plug in any x value, but your range is limited because your parabola turns around. They're not all going to be negative infinity to something. If they were concave up, it'd be something to infinity, right? But this one's concave down, so it's going to keep on going down forever and ever and ever, and the largest y value is going to be 9. And I just put in the x and y there just to help remind you. And I think that my next one is not in intercept form. No, it's in standard form. So that's the last one for this podcast. In the next podcast, it'll be just all the different kinds of graphs. And I'll go through just a little bit faster because I've gone through all the steps for you. And we'll look at standard, intercept, and vertex in the next lesson, which is a review graphing quad functions. Thanks for watching. Bye for now.